this video, I'm going to go over question 2 from the IB Math SL exam paper 2. So this is the calculator paper. Here we're given a function f of x on the window -3 to 3 and asked to find the coordinates of a, which is a local minimum point. So we could get the first derivative and set it equal to 0 to try to solve for the x coordinate of the local min, or we could just graph it on the calculator and look for the local minimum. So I'm going to do that. It's the most time-efficient method. Open up the calculator, add a graph page, and type in the function. It was 0.225 x to the third power and minus 2.7x. Okay. It graphs the function. When I hit enter, I only want to see between -3 and 3 on the x-axis, so I go to window settings and change them to -3 to +3 for x. That was menu, window/zoom, window settings. And now I can see the -3 to 3. I can see where the local minimum point is. I do want the calculator to get it for me exactly, so I'll go to Menu, Analyze, Graph, Minimum. Click on the left and right of it, and it gives me 2, -3.6. I'm just going to check my menu and make sure that the rounding, okay, good. There aren't more digits that are missing. So 2, -3.6 will be the coordinates of A, and make sure if it asks for coordinates that you're giving a point and not just the x value. If you attempted to do it by the derivative method, you would have only gotten x equals 2. You do need to sketch a graph if you used a graph from the calculator as part of your answer and indicate that this is the point that you found. On the following grid, we're going to sketch the graph of f, clearly indicating the point A, and then sketch the tangent to the graph of f at A. So this is testing a couple of things. On a graph, they're always looking for accurate endpoints, accurate intercepts, accurate max and mins. Those are the 3 things we want to try to make accurate. So this graph actually does have endpoints because they only instructed us to look between -3 and 3. So if we go back to where our calculator had graphed this and just check out the graph we're looking at, we want to make sure that our endpoints are as close to accurate as possible. This looks like it's at -3 at about 2. And then over here at +3, it's at -2. So I'm going to plot those as endpoints. And we know that there was a minimum point at 2, -3.6. So I can attempt to show where that would be. And I'm going to label it. It says clearly indicating the point A. So I'm going to label it A. And it also generally wants our intercepts to be accurate, or as close to accurate as you can. And it looks like it crosses right at 0, 0. So that's an easy one. And any max and min points. We already have a min point labeled. I'm just going to check out the max point, which looks pretty symmetric, so probably up around here. So now when I sketch the graph, I should try to create a nice smooth curve showing all of those points clearly. It does look differently on this paper than from the calculator just because of the window that we're seeing. And then sketch the tangent to the graph of f at A. A tangent line at a minimum point is horizontal, so you should be sketching the line like this. Make sure it clearly goes through your point A. And just in general, remember, tangent lines go the same direction as the curve. So if the point had been over here, you'd want your tangent line to look something like that. But of course, this one is just a horizontal one, so we'll show a horizontal tangent line down here at the minimum. And that is it.